Fine. My name is Masim Constellation. I'm here to present one of the topic that is energy transfer in electrical systems and under the chapter of energy and change. So I'm here with the introduction today that here today we'll be talking about the energy transfer in an electrical system by the way. So everything that here we're talking about the energy transfer in an electrical systems. And then we have some keywords here, which we have a circuit, and then we have electrical current. Here we have a simple circuit that contains of a cell and a closed switch, light bulb door, and then even the conducting wires. And then we can see again here that we have the learning objectives, which is the objective outcomes that must be achieved at the end of the lesson, whereby a learner must be able to identify the systems that transfer electrical energy. A learner must be able to describe the energy changes after the topic of energy transfer in the electrical system. A learner must be able to know the system that do not transfer electrical energy. All these things here are under the energy transfer in an electrical system. We're talking about the transfer of energy that is found in an electrical systems, which can be some devices such as a torch, a computer, a phone, anything that has a light bulb or has the light displayed on the screen, or a closed switch that control on and off, anything that has a battery inside and conducting wires. That thing is an indication of electrical systems that in that devices there's a light. As you see, they have a light bulb. In that device, there's a switch that control on and off. And then in that device, we have a battery as well. And then in that device as well, we have a conducting wires that circulate the electric current inside the device. So here inside this thing, that we rather have to understand the topic before we rather dive into the content today, that we're talking about the energy transfer that is found inside an electrical systems. We have the system that actually electrical systems such as torch, computer, phone, any device that can show a light on the screen or have a light, any device of console, like have a closed, have a switch which can be controlled open and closed there. You have a battery there which is cell and a conducting what shall we say, introduction here of the energy and energy transfer in an electrical system under the chapter energy and change. So now here we hear diving about the keywords and everything that we're going to be talking about here, referring to our sample circuit. So we have a circuit. First thing, a learner must understand what is a circuit, because that's what we're going to learn about here today in energy transfer in electrical system. And you have to understand what is a circuit. It's a pad with electric charge can pass through. That's a circuit. As you see, it allows the current to bounce and flow within the conducting wires, which a formation of light is being caused by the cable extension of conducting wires with the supply of the cell there, the battery, which is everything so that they can move freely there, and which is those switch as well. So now here we understand the circuit that is a pad which electric charge can pass through. So that electric charge is going to be passing through this electrical conductor, which is supplying the electric charge along the circuit. And then now we have electric current. That's what we're going to deal about in this energy transfer in electrical system. Electric current is a flow of current charge that is circulating through the conducting wires that is giving us with the information of a light that's supplied by the cell. And then now here we know circuit, we know electrical current, which is the keywords that need to be mastered today. So now here emphasizing that we have a simple circuit, which we have a cell, which is a code of this circuit, because without a cell, nothing won't function properly. And then we know here, since we have a simple circuit, which is a battery that is supplying the energy throughout the very much important about the cell. It is the core of this thing because without a cell, there is no light. There will not be a light, and obviously the conducting wires won't operate without the formation of a cell, which gives the energy to circulate around these conducting wires. So now here we have a cell, and then we have a conducting wires. Then it gives the circulation of the electric charge that can pass through these conducting wires, so that at the end of the day, you can have the formation of a light, and you have a glue switch that control on and off. It's a control device that control whether the light should be on or off. But although this thing come from the cell with the supply of a cell. And then here, now here when I was talking about this thing, that we know a cell has a chemical energy. A cell contains a chemical energy. But in the formation of light, people will ask a lot of questions about how did that light be produced at the end of the day. And when you go to our learning objectives, they say a learner must be able to describe the energy changes. That all of these things, when I press on here, so that I can have a light, what happened? And a learner must be able to explain what happened throughout that process. We have a cell here, which is a battery that was being charged from electrical current, from electricity. And then when that cell is fully charged, when they tell that thing, you know, the electric charge is all circulating around that cell, which giving it an electrical charge to be circulated around that circuit. Now the device is full. That electric charge is full here at the circuit, which is supporting the electric charge along the conducting wires. And therefore, now we know the chemical change, the chemical energy that has been found there is being converted to electrical energy in a formation where the electric charge is being supplied all through the conducting wires, and then they form a light. And now from the electrical charge, then now it's diving into the light energy. And then after the light energy has been formed, which is the energy, now there's a conversion. When that light is being on for too much of a lot of time there, then you can see that a light now start to be hot because the light energy is being converted to heat energy. And then here we have an objective outcomes. What a learner needs to know at the end of the lesson, that a learner must be able to identify the systems that transfer electrical energy. And then so surely here, an example of the system that transfer electrical energy, we can have something like a torch, which has a cell, which has a switch, a control on and off, and it has a light bulb. As well, it has a conducting wires, and then a torch can be one of the systems that can transfer energy, because there's a lot of transfer energy inside a device of a torch. We have a computer. Computer has a conducting wires, has a cell that you control on and off, and then as well has a light, displaying a light on the screen, which can be represented as a formation of a light bulb. The light that is being displayed there on the screen. As well, we have a closed switch. We have a system that can control on and off of the computer. Same thing happens to a phone. So the conclusion about this thing is that here learners need to understand that here we are talking about a circuit, and then here which is circuit and electrical current. So they have to know all of those changes happening here inside the assembled circuit, that we have chemical energy stored inside a cell is converted into electrical energy after the cell is being fully charged. And then the electrical energy and is converted through the electric charge that is running through these conducting wires. So electrical energy is being changed to light energy. That's the formation as we have a light displayed on the screen. And when that thing is being there, light for too much of a lot of time there, then that light energy changes into a heat energy, whereby you can feel that the globe is very heat, or the screen is on heat. It's because light energy was being on a light for too much time, and surely then that light energy changes to a heat energy. So now, here, when we have a sample, that thing, the formation of all those electrical charges running around the conducting wires, they run by the process of we call kinetic energy that is being supplied from the cell. It gives all those kind of electric charge to circulate here, so we know what the thing a learner must be able to identify the system that transfer electrical energy of which will be identified by the formation of any system that has a cell, a switch, and then light is being displayed on that device or the conducting wires. And then a learner must be able to explain the energy changes of which I've explained, and then a learner must be able to know the system that do not transfer electrical energy. Any system that doesn't have a cell or one of the components that found here is not present, like a cell, like a light being displayed, or a conducting wires. If one of basic components that are not there, that thing cannot conduct electricity in those devices. We have devices like such as maybe where we have something like a bucket, that thing, the operating with no function of a cell, no conducting wires, and then no light being displayed on that thing cannot conduct electricity. Maybe a horse on the grass, we know there's no cell, it's operating in the absence of a cell, conducting wires is not there, and the light bulb and the closed switch there that control on and off is not there, as well. I think cannot conduct electrical system that we found here today. So now we can have something like this marker here is operating, that thing cannot conduct electricity. Why? Because it's operating in the absence of a cell, no conducting wires, and then no light can be displayed from this marker, and as well no control switch which can be on and off. And so that is that's where after this new objective, that's what the learner must know.